Well, good day, everybody. I'm Russ Reed, and I'm the Executive Director of the National Center for the Biotechnology Workforce, located here at Forsyth Technical Community College in beautiful Winston-Salem, North Carolina. And this is SciTech, and SciTech is very exciting. It's a lecture series that we offer for our students and for our faculty and staff, and it gets broadcast right around the world, which is pretty exciting. And I just want to say hi to Trevor Tufano, who's our trusty ed technician. Trevor, how are you doing today?
Hi, Russ. I'm doing great. Thank you for having me.
Good, Trevor. I understand, Trevor, you had a bit of a break, and so you're feeling really relaxed, and you went to the beach and so forth. That's great. That's what North Carolina is all about, right?
Mm-hmm.
So, Trevor, today we have really special guests, and so I'm very excited about this. A colleague of mine, Dr. Jana Stoudemire, is with us. She works with me on the engine, which we have here at within our region, and the NSF engine is a very, very unique thing. We're going to talk about it a little bit with Jana today and figure out about its implications. But the whole topic today is space and space biotechnology, and our special guest is Dr. Pinar Mesci from Axiom Space. Pinar, welcome, and Jana, welcome.
Thank you.
So we would like you just to talk a little bit about yourselves. So Dr. Stoudemire, you'll go first, please. Thanks very much.
Sure. Well, thank you very much for having me today. And I appreciate the honorary degree, but I don't fall into the PhD category. Pinar is going to represent us there. But from a perspective of my background, it's very interesting for me because I transitioned from traditional biotech, pharma, medical device, a couple of decades that I spent in the industry. And then when I learned about work that was going on in microgravity, it really kind of changed my perspective on how to think about biology. And since I heard innovation many times throughout my career, I was very lucky to work on leading edge technologies while I was working terrestrially in the industry. I think the true innovation that microgravity really brings, and Pinar will talk more about this, is something that is not just perspective changing on biology, but on the way you look at your research. And so my transition to the space industry about 10 years ago, I started with the ISS National Laboratory, managing life science research on the International Space Station. I moved to a company called Space Tango that actually has facilities on the ISS, and then to Axiom Space, which is building the successor to the International Space Station and will be the first commercial space station that will be attached and docked to the ISS in a couple of years from now. And you'll hear more from Pinar on that as well.
Well, that's great. Well, thank you, Jana. I really appreciate it. Pinar, please tell us a little bit about yourself.
Yeah, and thank you so much to all. I'm very happy to be here as well. And thank you, Jana, for the kind words as well. So I'm Pinar Mesci. I'm a senior program manager here at Axiom Space, in charge of a portfolio of programs focused on in-space biomanufacturing. So these range from stem cells, tissue engineering, 3D bioprinting, DNA-inspired nanomaterials, or cancer research as well, among others. I know that Jana has already given a little bit of an introduction to Axiom Space, but what we do here is, as she mentioned, we're building world's first commercial space station, but we also have the unique vantage point where we can actually directly connect to the ISS. Our first module is going to be connecting directly to the International Space Station. And then from that point on, we're going to start building our station module by module, and then eventually become a free flyer upon ISS before the ISS is decommissioned. So our company is really trying to make sure that anyone and everyone can have access to low Earth orbit. And we do that through our, of course, commercial space station. But while we're making that, it's currently being manufactured. We have also conducted 3 private astronaut missions to the International Space Station. We have our 4th one coming up in the next couple of months. So these are short-term duration missions during which 4 private astronauts can conduct, or commercial astronauts can conduct different types of experiments. They don't necessarily go there just to observe, but they are actually pretty packed as far as all the experiments that they need to do. In addition to that, we have been also chosen by NASA to develop the next generation spacesuit for Moon. So we are actually making that, and that's also in collaboration with Prada. So some of you may have seen our spacesuit through that connection. And then finally, we are also collaborating with Astrolab on the lunar terrain vehicle for exploration.
And that is very exciting. I'm going to, actually, I'm so excited. I'm going to transfer it over to Trevor so that he can ask you a couple of questions.
All right. Yeah, sure. So, Pinar and Jana, you both talked a little bit about kind of some of the different things that Axiom Space is working on. Is there anything else that you'd like to tell us about Axiom Space itself?
Yeah, maybe I can speak to a little bit more in detail to what I'm doing in the company and how Axiom is also helping develop some of the low Earth orbit markets. Because, of course, as Jana said, this is a unique environment that has so much potential, but it's also because it's new. We have to still do a lot of understanding of how we can leverage that to benefit life on Earth and beyond. So basically, if we are thinking of gravity here on Earth, it's pretty much in our everyday life, right? So if we're thinking from a physical stance or chemistry or things like that, if you're thinking about the formulas, the mathematical formulas, there's always a G component there that we don't even think because it's the constant, right? But now imagine that you have to actually remove that. And what does that do to your system? So if we're thinking from the point of view of advanced materials, there's a certain fields that have already seen some benefit to it. So this, for instance, include fiber optics. Flawless Photonics, a couple of months ago, they have actually were able to pull up to 12 kilometers of fiber optics in microgravity in 2 weeks, which was a record time for pulling that much fiber optic. So for anything that is advanced materials, there has been a lot of studies done since the shuttle times. But on the bio side, although there is like some anecdotal unique experiments here and there, because of lack of being able to repeat experiments and getting very robust data, the impact of microgravity on biological systems remain a little bit less known compared to advanced materials. And this is where Axiom has spent a lot of time and also is very much supportive of trying to understand which fields in the biomedical field can really benefit from microgravity and how can we leverage that to make unique products to benefit life on Earth. How can we leverage that to find unique therapies that we're not able to find any therapies for instance, cancer. I mean, I know that anyone and everyone has someone that they know that has been touched by cancer, but unfortunately, most of the times we don't have any cure. So we are really trying to find these products and try to, of course, later on develop them on our station for manufacturing.
That's great. Thank you for telling us just some more about some of the different things that Axiom does, Pinar. That's great. So kind of continuing on, can you tell us a little bit more maybe about in space biology and biotechnology, maybe sort of just like the why of it and some of the different, aspects of it?
Yeah, again, I mean, I think the really why of it is really trying to find how can we look through a different lens. So far, everything that we have done here on Earth has that gravity component. What does that mean for biological systems? It means that there's an aspect of sedimentation, for instance, that we don't necessarily think about, but when we're trying to develop model systems for different diseases, for instance, well, that can be not as good because we may not be able to produce disease models that are as accurate as we have them in our body. And therefore, if we don't have good disease models, we will never be able to find the best cures or treatments for those conditions. We can also think about how like I'm going to give one of the examples of one of our partners who have flown with us in all of our Axiom missions, and they're going to also fly during AX4. So this is our collaboration with the Sanford Stem Cell Institute. They are interested in how tumor organoids can grow in space in microgravity. So far they have tested colorectal tumor organoids and leukemia tumor organoids and triple negative breast cancer tumor organoids. And basically what they have seen is that in microgravity, in a shorter period of time, they see a much bigger growth compared to here on Earth. So it seems like microgravity has this acceleration aspect to that, to those organoids. But they have also seen that the pathway that they're interested in, the disease pathway that they're interested in, ADAR1 pathway, this RNA DNA editing enzyme, is actually more present and more active in microgravity as well. So based on these observations, not only they were able to conduct these experiments multiple times, so then you get a repeatability, have a more robust data set, but they were also able to test drugs, one actually FDA-approved drug, and then one that the team is currently developing, ribaxinib. Luckily, what we have seen on orbit was that even if we see this accelerated growth of these tumor organoids, the drug that they were developing was actually able to limit the growth and actually inhibit that pathway. What does that mean for patients? So now if you have this model where you have you leverage microgravity to screen drugs, now you can see which drugs, even if there's a more aggressive cancer type, they have more chances of working in patients as well. So those are some of the examples that I can give that can really see a benefit from from leveraging microgravity to really benefit patients.
That's
Yeah,
great, Pinar.
Trevor,
Okay, go ahead.
I'll add a little bit there because, the applications that Pinar is talking about, even when you think about gravity is not in everything we do every day, the products that we're talking about making, whether they're for technology, advanced materials, biomedical, we're really talking about things that can't be made here on Earth. So it's hard to get your head around sometimes what would we use it for? Because today we don't have it, right? And we like to think about this kind of in the sense of there are things that you can't imagine that we could make today, but you won't be able to imagine how we lived without once we have. And so it's really a paradigm shift for both healthcare and technology that space provides to us. We're not really just looking for incrementally better, but we're looking for how do you leverage that environment to do things that can't be done here on Earth, but have significant benefit to things like healthcare burdens, cancer, Parkinson's, MS, right? Neurological and neurodegenerative diseases, drug delivery systems, the nanomaterials that Pinar talked about. What's really inspiring is to think we could make perfect nanoparticles that could penetrate thick tissues or hard to penetrate tissues and be stable at room temperature. We don't even have today lipid nanoparticles that are used for most drug delivery systems. Even when you think of mRNA vaccines for COVID, the distribution chain for that was a cold chain. And to be able to do that stably at room temperature and more perfectly with materials that are less toxic and easier to penetrate, difficult to reach kinds of tissues, that opens a whole new way to address how we treat diseases. So when you're thinking about microgravity, not only from the perspective of a true innovation platform from the science, think about it in the sense of products that we don't have today, but we could make there and we can't make here.
Mm-hmm. Yes, definitely. Thank you both very much for kind of elaborating on that and telling us more about it. I think it's very, but both fascinating and also kind of very exciting to see, where space biotechnology and biology will be, going here. So thank you very much for telling us more about that. So my next question, kind of going off that a bit, is so how does in-space biology and biotechnology connect to the Wake Forest Institute for Regenerative Medicine?
So I'm going to start and then I'm going to let Pinar talk because she is the program manager for two projects that we're working on directly with the Wake Forest Institute for Regenerative Medicine. One is a NASA funded, it's called In-Space Production Applications. And it's a project that looks at vascularization of thick tissue. So the Wake Forest team won the NASA Vascular Tissue Challenge a couple of years ago, showing that on the ground they could make 1 by 1 centimeter thick liver tissue, and that it could maintain its metabolic function for 30 days. So when they won that, we talked about the opportunity to what would that look like if you were able to continue to grow that tissue in space? So printed on the ground, not necessarily on orbit yet. And when we think about the idea of ending the organ shortage, we all are striving for the day when we can bioengineer human organs for transplantation. I know personally my career, I've spent 35 years hoping that that would be the case. It's hard, right? Biology is just inherently hard. And thick functional tissues like liver or kidney are very difficult. So what we proposed to NASA after the Vascular Tissue Challenge was a stepwise approach of building blocks of thick tissue that could be used as a bridge to transplantation. So for example, if you could make bigger than 1 by 1 centimeter, maybe something like 1 by 3 centimeters or 1 by 7, maybe even, and use those to come up with about 100 grams of tissue, you could replace a lobe of a liver and you could bridge someone while they're waiting for an organ to become available. That project is super fun for us because we're looking at things like cell matrix interaction and opportunities to understand vascularization, which is a limitation to creating those thicker tissues that maintain their function. We also have a Center for the Advancement of Science in Space, CASIS, who is the manager of the ISS National Laboratory, Igniting Innovation Project, looking at an AI-driven patient tumor organoid model. That project is really fun because in the cancer space, the Igniting Innovation Awards were aligned with the White House Cancer Moonshot goals. And what we said was, and I didn't know this until we started putting this proposal together, but colorectal cancer, left and right-sided, responds differently, just inherently. But nobody really understands why. And so we want to look at that phenomena in a gravity-free environment and understand how we make chemotherapeutic treatments that are more effective for patients. So if we can understand mechanisms and we understand what genes are on or off in that environment, when we're seeing that with sort of the veil lifted on biology, that gives us tremendous insight to think about how we would approach treatment and how we would make treatments safer and more effective. Pinar leads both of those initiatives. They're going to have multiple missions to the International Space Station. So maybe, Pinar, you can talk a little bit about the logistics of moving biological payloads from the ground up to the International Space Station.
Of course, yeah. And thank you so much, Jana, for this wonderful overview of these two programs. I mean, one thing that I wanted to add for the first program that you mentioned, the INSPA, with the constructs of kidney and liver tissues. I mean, of course, one thing that we have as limitation here again on the ground is gravity. Gravity means that there's sedimentation. Sedimentation means that some of the tissues, as we are building them, one of the main limitations currently on the ground is that because there's gravity, those constructs might collapse. So, and that therefore making the vascularization aspects from a modeling perspective a little bit more, way more difficult. So this is one of the reasons why we are also leveraging microgravity, because of course, in the absence of gravity, the hypothesis is that those constructs will be better maintained and then grow more because they're not going to be subjected to the gravity's pull and hopefully grow better. And then, from the logistics perspective, of course, these are, in the case of the NASA INSPA award, these are actually multi-phase applications. And again, these are really efforts from both NASA and Axiom has been extremely supportive of all these initiatives, is to see, okay, so which products can we really make that we cannot make on the ground, or that there's a paradigm shifting result that we really need to make them on orbit, and that will actually justify for the potentially the increased request for funds or things like that to be able to make them on orbit. So we are currently in the phase one. The phase one being really generating the proof of concept data. So the first question is this project really going to benefit from microgravity? Because if we are not going to see any benefit, then there's potentially no need to in pursuing that towards all the way to in-space manufacturing if we can make them similarly on the ground and on orbit. So also that's another point. So every time that we do an experiment, we have parallel controls, meaning we make the ones on orbit, but on the ground we do the same exact experiment in the same hardware and with the same materials from the same cellular sources on the ground to really make sure that the effects that we're seeing are due to microgravity and nothing else. So these are all things that we are working with the teams, and also we collaborate a lot with BioServe Space Technologies, who are helping us in this collaboration. Of course, they're pioneers in this types of biological payloads. So as I was saying, so we are currently in the phase 1 of this program. And in order to really be able to generate a good, robust data set, we are actually giving the unique opportunity to be able to fly multiple times during that 2 to 3 years of the initial phase. So that gives us not only to incrementally make the systems a little bit more complex. So in the case of this INSPA award for the Wake Forest, in the first mission, we're going to be flying a system that is going to be the first version. And in the second flight, we're going to fly a system where we will be able to add some sensors. So we're going to be able to get some telemetry data back while we are on station. So real-time data, which is also very important in accelerating the discovery and the science. And then once we are able to do these, generate these proof of concept data, if everything looks good, then we are given a chance to go to phase 2, which is pilot scale manufacturing. And this is, of course, where Axiom Space is also very supportive, because we are tailoring our space station according to that, so we can support these efforts. And then once the pilot scale manufacturing is also showing promise, then we can go full on full scale manufacturing. And hopefully by the time that we're in phase 2 and phase 3, the programs are built in a way that we are supposed to not only rely on government funding, because of course for this types of projects we need also industry and private partners coming in. All the teams that we are working with, we are trying to bring in other industries and try to patent certain aspects, and so then we can do licensing to other companies, and then potentially attract other pharma companies that might come into play and help with building this low Earth orbit market, basically. So that was for the INSPA, and then for igniting innovation part. Again, that's also going to be a 2 to 3 year project, and again, this having robust data sets and repeatability is very important. So that's why we are going to be able to do multiple flights to make sure that the results that we're seeing are actually what they are. And then, hopefully come at the end of that program with a couple of candidates that we can continue pursuing, either with other funds or maybe bringing some of the private industry partners into play.
And I'm going to add one more thing, because, when you listen to Pinar talk about pilot and then future commercial scale manufacturing, that's not something we could ever think about with the International Space Station today. We don't have the space, and it certainly doesn't meet the cleanliness requirements and GMP requirements that would be needed to be able to really manufacture in space. So infrastructure from the commercial companies is important, and the support that Axiom has given. The other fun thing about these projects is this team already has spaceflight experience. They flew with us, Wake Forest, on the Axiom 2 private astronaut mission, just as a precursor to these upcoming INSPA NASA missions for thick tissue constructs. And that's a key differentiator in the way that Axiom helps their teams, right? Because by the time that we're actually starting our first real flight for this proof of concept, we already understand the mechanics of going to space, which is a little different. Getting on a rocket and putting your tissue constructs and sending them to the International Space Station is not quite like working in the lab. I mean, it is, but there's a complexity to it. And Pinar, as the program manager, is just phenomenal with her background and her transition, which we'll talk about a little bit more about skill sets and what's needed to do this. But, that, I think the precursor missions, getting everybody really ready to take advantage of these multiple missions that we have funded under NASA and CASIS, ISS National Laboratory, this team is ready to go, and we're super excited.
Yeah, that's great. Well, thank you both very much for sharing more about that. It definitely sounds like there's plenty of exciting projects on the horizon. So thank you for telling us more about that. For our next question, I'm going to go ahead and turn it over to Russ.
Yeah, thank you very much. This is very exciting. And thank you, Pinar, and thank you, Jana, and thank you, Trevor. Jana, this is business, right? This is talking about the RegenMed engine grant that we have. How is this going to affect the region here? What's the implications?
So, Russ, I'm so pleased that when the Wake Forest team was looking at the Piedmont Triad Regenerative Medicine engine, they also looked to the next generation of biomanufacturing for regenerative medicine products. And as the lead for the in-space ITEC of the PTRME engine, our goal is to advance processes, products, commercialized, like you heard Pinar talk about, right? So the space initiatives are not research and they're not for future exploration about keeping people healthy as they travel from Moon to Mars. It's about benefit to life on Earth and creating those markets. We also see an opportunity to bring a whole new industry to this region. The space industry really leverages the leaders in the areas of regenerative medicine and other biomedical sciences. They're looking to the lead teams to help them to understand, how do we do that better? Or how do we get over the hurdles that we have on the ground by using space? Because we see these opportunities for these emerging markets as rivaling this current satellite market, right? Which just takes advantage right now of the vantage point of looking down or communications. So everyone knows about the Starlink networks, and, the commercial space economy today is really about Earth observation or communications. What we're looking at with in-space manufacturing is an opportunity to leverage microgravity and the vacuum of space, the conditions that exist up there that allow us to make these materials that we can't make here on the ground. When I think about space coming to the region, I think about it from multiple perspectives. It's not just the commercial space companies, it's also the implementation partners who know how to send payloads to the International Space Station and future commercial space stations. It's venture capitalists who are interested in helping to invest in these emerging markets. I like to think of what we're doing with creating these new markets 250 miles up as really just expanding the definition of global. When you think of world economics in the future, it's not going to be just what's on the globe. It's going to be what's happening in space as well. And when I think about investors, industry, commercial space companies, those are all jobs within our region. Those are all future opportunities to train a workforce, not just on regenerative medicine, but on next generation biomanufacturing methods that they can't probably envision today, but the translation of the skills that they have for doing regenerative medicine on the ground, transitioning that to the space environment, that's the next step. It's the future of where we're going.
Well, Jenna, that's a great explanation. It leads me to the next question, which is fairly obvious. So, we're a college, right? And we've got faculty and we've got staff and we've got students. How does one get involved?
So I'm glad that you asked that, because for us, engaging the next generation of students who will become the workforce at all levels. We're going to launch a Postcards to Space campaign with Blue Origin for K through 12, just to introduce this concept, right? And it's about writing your postcard, give us your best regenerator cell, like it's cell biology themed. So we're already getting them to start thinking about regenerative medicine in space and the fact that we're doing it here in the region. Internships. We have opportunities through Axiom Space has a laboratory in the Dean building. We're looking to staff that with interns from across our region. We're asking our implementation partners to take interns from the region, bring them into their companies all across the countries, and work together with them in the summer to understand what it's like to send biological payloads to space. We're asking those same implementation partners to come in to our community and spend time so that the students who can't travel, maybe to Colorado or Houston or they'll still have that same opportunity to have exposure, to learn what it's like to send a payload to space. We've talked a lot about formal programs too for training. Like there's a NASA STAR program that helps to bring researchers to NASA. We'd like to do that program, but bring NASA and space and commercial space companies to our region so that we have the ability to give that kind of perspective, have people understand that there are training courses that we can set up, just like you would get a certification for biotechnology. We'll have a certification someday for space, right? To say that you're the person that understands, like Pinar, who's the expert in telling you how to get a biological payload that needs to be kept at 37 degrees while it's on a rocket and cells have to be fed. And how do you do all of that, right? It's not a mystery. We've figured it out. We do it all the time. We'd like to translate those skills to the region as well, and eventually have companies that move to the innovation quarter and within the region, PTRME region, so that we have opportunities that once we have a trained workforce, they're going right to the companies who are already established within the Piedmont Triad region.
Super exciting. Trevor, is this registering with you that we're going to have in the future space here? I mean, we're going to be doing space manufacturing, biotechnology. This is very, very exciting.
Mm-hmm.
So, Jana, a little bit more on skills. Can you and Pinar maybe just identify those skills that we think we need to be teaching our students right now? Yeah.
Absolutely. And I'm going to let Pinar really talk about this because she is probably the perfect person to talk about the transition from what you're doing today that you might not necessarily see transitioning over to the space industry. But just at a high level, what I will say is that most people think of space programs right now as rockets, engines, robotics. So when they're thinking about careers in space, they're going down this path of sort of aeronautics. When you think about biomanufacturing in space, we need all of the same skills that exist today in a biomanufacturing cohort to come to space. So I don't want the people who know about rockets. I don't want the people who know about robotics. I want people who know biology and who know about biomanufacturing, which is not always clear to everyone. And, in general, I would say when I talk to students, I always say, imagine anything you want to be here on Earth, you can be that in space. We need people who know how to sew to make the spacesuits that Pinar was talking about, right? And a lot of the teams at Axiom working on those suits came out of Cirque du Soleil or theater where there was precision sewing, and spacesuits just takes it to that, no pun intended, next level of precision, right? So, but sewing, food, we need to eat while we're there. So people need to figure out cooking and nutrition. We need to understand space policy, space law, tax. If we're going to set up a commercial market up there, just like the internet, you bought things on the internet way before people figured out what e-commerce was and how to tax it, right? So almost any career that you can think about on the ground is something that we're going to need as we expand the world economy to include space. But the specific skills on regenerative medicine and biomanufacturing, you have no one better than Pinar to talk about what that transition really looks like. So Pinar, I'm going to turn it over to you.
Yeah, I mean, Jana, I couldn't agree more with you. I mean, before I talk about my experience, I mean, when I used to be in academia and thinking about space industry, well, it was like mainly engineers and, mainly engineering background. So I was like, there's nothing really to do for like biologists or neuroscientists or stem cell biologists like myself. But yeah, I mean, my experience has been truly something that I could have never dreamed of. So basically, I was prior to joining Axiom and at UT San Diego for almost 10 years. Prior to that, I was in France where I did all my studies. I had my bachelor's, master's, and PhD there in neuroscience, and then moved to California to work with stem cells, human stem cells, and brain organoids, and was leading multiple projects, but then some of them were like mainly focused on autism, Zika virus, coronavirus. But then one of the projects, brain tumors as well. But one of the projects that we were starting was trying to understand the impact of microgravity on human brain development. And this really started as a side project in the lab, and I was leading that with another colleague of mine. And then we flown to the International Space Station 4 or 5 times within the time frame that I had started the project. And each time I learned something new about how to implement, not only thinking about my science differently, because you have to also think about from that point of view, because you're going to be asked a lot of the constraint questions, since it's not necessarily, although we are trying to make it as seamlessly as possible, but it's not as easy as going necessarily to the next bench and kind of grabbing your cells and going under the hood and feeding your cells. It's a little bit more complicated. So it forces you to think differently from the science perspective. It actually helps you understand your science better, because you have to know all the constraints of your system, what it can tolerate, what it cannot tolerate. In the process, you develop new technology. Like, I mean, I'm going to give this example because I think it's simply genius. One of our teams, National Stem Cell Foundation, they have flown multiple times to the International Space Station as well. And one of the things was like the hardware that they were using. Well, they wanted to have some kind of backup. And one of the things that they thought about was, well, what if we were to put brain organoids in a cryo vial and then just keep it there for a month? And then initially, even within the team, they were very skeptical. But then once they started doing the experiments, it turns out that it was actually feasible, which led to, of course, the team getting a patent, and now a lot of the other teams across the world are using the system. And like, just now imagine, instead of like trying to feed your cells all the time, imagine you just have them in a cryo vial. It's a small tube, and it can easily be shipped from places to places. It can have a lot of applications around the world as well, for collaborations, if you want to share organoids, samples, things like that. So that's one aspect that I think it really helps us. And then just to going back to my own experience, so I was doing those experiments and had sent a couple of payloads, and I had at that point a pretty good understanding on how we were preparing for launch, which takes multiple months. There's multiple critical time points that we have to see if we can make it to the flight. That I got to learn. And then at one point, I think I was maybe a little bit frustrated with academia, and this is where networking comes into very handy as well, because Jana and I, we were just keeping in touch, and of course we are both local here in San Diego, so we were often chatting. And then one of the things that she had mentioned to me, well, what about Axiom? Like, would you ever consider working there? I'm like, but like, how? What would I do? Like, that company is making the commercial space station. At that time, we had not received a spacesuit contract yet, and some of the other things. And it was like, no, they're about to start a lot of these in-space manufacturing programs, and I think you'll, with your skill set, with the program management and all that, you will be perfect for that role, because you already have done your own experiments in space. And, and then of course you can learn more in detail the space side. But at first I was a little bit skeptical. I gotta say, I was very, very, not only skeptical, but also very afraid of the change, because it's a drastic change. And also, mind you, there's not another example I can turn into to say, hey, how was it for you, this transition? Because, I mean, thanks to Jen, I'm one of the 2 people who have transitioned to space field from stem cells, and the only one that who has transitioned into commercial space. So there was truly no one, but I mean, the fact that she believed in me, I think it really gave me a lot of confidence. And also the team that we are working with at Axiom, they're very open-minded to new things, and they took a chance on me, and it's been I think really enriching for all of us to have these different backgrounds, because I think that's where also innovation happens. When you are working always with the same type of people with the same background, you don't necessarily generate new ideas or find new solutions. But I think with like some of these different background people, we have better chances of succeeding. So one thing that I would say that I had to learn as well. I mean, maybe I had that a little bit in mind, but it's not something that we necessarily think about it in academia a lot, especially when you're a student. Is something to keep in mind is like always what's happening around the world, not only in the US, but also around the world, because everything might have a ripple effect on how things work. And also that helped me also develop some business development skills as well, because also knowing what's happening in the different world makes you help establish collaborations with different groups as well. And, knowing a geopolitical situation might help you creating new hubs for certain fields. So I think that is an aspect that I think it's very important, especially in the space field, because we're all one basically, and everything can influence each other. And space is a place where we can all work together. And that's what Axiom is doing as well, with all these private astronaut missions, enabling all these countries who have not previously flown to the ISS or to space, who doesn't have any space program. We are all trying to help everyone to get to a low Earth orbit and benefit from it.
Amazing. Trevor.
Yeah. So, thank you both very much for everything you've shared so far. So just to kind of, I guess, tie things together, do either of you have any, it could just be insights or any just additional things that you'd like to add about anything that we've discussed today? It could be just about in-space biology, biotechnology, anything.
Yes, I would say I would like to leave everyone with the thought that anything is possible and the sky is no longer the limit. And so think bold, right? When you're thinking about, Pinar is very humble. And when she says, took a chance on me, no, what we needed was the science that she knows. That's what we need. People who are already trained in a discipline coming to space, we can teach you the space part, but we couldn't teach you the biology part. It's just like having an implementation partner who knows how to make hardware, but doesn't understand the biology that's going in it, right? So it's a unique opportunity for us to combine skill sets like that. But I just want everyone to know it's happening right in this region. We're already working on it. So think big and bold, and the future is very bright.
And I just wanted to add to that point also, when we're thinking from a regenerative medicine perspective, because this is also a field that is requiring a very specific skill set, it's also important to have people who are actually experts in this on the ground, being able to not only do some of the experiments in space, but also help with these experiments. Because I'm going to give one example that I think has blown all of us away when we're actually watching the mission operations during AX2 mission, is because during AX2 mission, we actually flew the first Arab woman, the 600 person for the ISS, and it's Rayana Barnawi. She's a stem cell biologist, and she had very good skills at the bench, and it was her first time. And I'm just gonna tell everyone, I'm personally afraid of going to space. I'm afraid of roller coasters and things like that. So I myself have never really considered going to space. But seeing her, how at ease she was, and then she was in her element under the life sciences glove box, which is basically the hood that we're using on the ISS. She was so much at ease and she was having so much fun. And that's the one moment I was telling myself, wow, maybe I can go one day to space as well. She really inspired me in that way because she was so at ease. And not only that, but all the experiments that she did, which were quite complex. So she has helped us with our work with Cedars-Sinai, for instance, who are making cellular reprogramming in space. So she has helped us doing the preliminary experiments for that NASA INSPA award that is establishing stem cell therapies in microgravity. And she has done an amazing job doing that. And actually, even though this was somewhat of a complicated experiment and there was a lot of firsts, she did everything perfectly, which really points to the importance of having subject matter experts who are also who can also come in this conversation and hopefully one day doing these experiments on orbit. I know that we're not the only ones necessarily thinking that. There's a lot of different hubs across the U.S. who are really thinking of, and not only U.S. actually, it's globally. It's everyone has voiced a lot of these ideas to have astronaut scientists, and Ray was a perfect example for that. But hopefully, we'll have more and more of those opportunities, and that's, I think, part of the workforce development that you guys are doing here in this region as well.
And Pinar, I'm going to add one thing to that, because it's not just scientists, it's people that are trained in techniques like GMP manufacturing. And when you think about a 6-month stay on the ISS to work, it sounds extreme to think you're going to get on a rocket and be a scientist or a biomanufacturing technician that knows GMP techniques to manufacture. But when you really think about it, it's not that far-fetched. Today on the ground, we have people who go out and fish as commercial fishermen for 6 months in really difficult conditions. Divers that go out on rigs for 6 months. The only difference is, instead of taking a plane to your job, you're going to take a rocket. And you're going to stay there for 6 months, but the same thing that you'd be doing in the biomanufacturing facility here on the ground, the GMP facility, you're going to do that on orbit. And the scientists right now are going to help us to figure out where those applications for in-space manufacturing that really benefit life on Earth are going to be. So you're not seeing a core of astronauts that are pilots and builders. You're seeing a core of astronauts that are scientists and future manufacturing experts. And to me, our region is rich in those talents and capabilities already. Transitioning them to space is the next opportunity that I think we really have.
Amazing. Trevor, I don't know what to say other than to say thank you to Pinar and Jana for coming on today and spending so much time with us. And I think this is going to go down as one of the best SciTechs we've done. So I want to thank you very much, Pinar, and please thank Axiom Space. And Jana, thanks for setting this up. Really, really appreciate it. Trevor, always good. This one's great.
Yep, I agree.
Awesome.
Thank you so much.